We've gone through compound registration and we've showed you standard design structure checkers. So now we'll go back to the core and Mitzo will give us an overview of what's happening with JChem Base Marvin and the cartridge.
Before I started, I have to tell you something. And don't worry, this won't be a story. That's something that presenters usually start their talk with. It's a simple statement. It's not me who should stand here in front of you. But who? Guess who? Who knows who? Szabolcs, yeah, him. Do you know him? I'm sure you do. But where is he? He's gone. He left the company about a month ago. But before he left, he asked me personally to do this talk in his behalf. And you see, I couldn't say no because he's my friend. But you see, unlike him, I'm not a product owner. I can't speak from the product's perspective about the great new features, about JChem's daring plans, the road ahead, the bright future, the great features that we developed. I can't because I'm not a product owner. But I could speak from this angle, but then it would not be my most authentic self. I don't want to do that because I'm a Scrum Master. So I would like to speak from my angle, from the Scrum Master's perspective. What's the Scrum thing? Do we play rugby at ChemAxon? Of course we don't. Scrum is a lightweight, agile software development framework that we use in ChemAxon to develop software for you. Now in Scrum, we have 3 roles: the product owner, the team, and the Scrum Master. Now while the product owner knows what to build, and most importantly, why to build it, and the team knows how to build it, the Scrum Master, me, helps them to do it fast and to very high quality standards. So for this talk, I would like to take my PO hat off and speak from my angle, from the Scrum Master's perspective. I would like to talk about how JChem Base is developed. How does development look from the inside? Okay? Is this interesting for you? How do we do it? Yeah? Okay. Now let's get started. Who knows this thing, the sausage principle? For me, in general, it says that making things can be rather messy and sometimes violently dangerous. That's Ukrainian parliament and this much about how law is made. Do you still want to come with me to this journey and see how JChem is being made? It's going to be messy and violent. Okay, let's go then. It all starts with something we call a user story. A user story is a deliberately short and often vague description of a new feature, a functionality. As it is not a detailed specification, the story gives enough room for the users, for all stakeholders, for the PO, for the dev team, to think about it, to really understand the requirements, to understand the new feature from the whole system's point of view, from the whole global product scope, and most importantly, from the user's perspective. That's the most important thing here in user stories, that it's from the user's perspective. Now, after some discussion, which happens in the so-called planning meeting, where the product owner brings this story to the team and they discuss it about the goal of this thing. After some discussion, the team provides a so-called size estimate. Now, typically, this happens, that's a planning meeting here. There are the story cards laid on the table. So the way how we typically give size estimation is called the planning poker. Yeah, we play poker. See? That's fun, real fun. No mess, no violence. Okay? Now, with this size estimate, the PO can roughly tell when this new feature will be done by the team, when he can release it and deliver it to his customers. However, some discussion happens in the planning meeting, and we better understand the story, we can better formulate it, we may even add some acceptance criteria to it that enables us to say when we are done with the story. So even after some discussion, the story is still fairly vague and quite uncertain. But instead of discussing more and spending more time on guessing what to do, the team chops off a little bit of the story, something that they think or rather feel can be done in 2 weeks. Yes, just 2 weeks. And they start work on this new feature or the story immediately. They do everything that in traditional software development has to be done, right? They do requirements analysis, they do high-level design, low-level design on, I don't know, on the level of classes, for instance. They do the implementation, so they code. They write tests, lots of tests. They even write the documentation, all in one. At a time, instead of being in a phase like doing the design for 3 weeks, they are always focusing on one feature and all aspects and all phases of one feature, okay? They do it for 2 weeks. This 2 weeks is called the sprint. Now in the sprint, the team meets every day for the so-called stand-up meeting. That takes 15 minutes. We often call it a daily scrum. And there the team shares experience. What did they do the day before? They feedback each other. They see where they are. And based on where they are, they decide what to do in the next 24 hours. Now, here on this image, it's not the JChem Base or the JChem Cartridge team. That's another team just living next door. That's the core and I team. But it doesn't make big difference which team we talk about in ChemAxon. Okay? All teams do that. They all have a daily stand-up meeting to see where they are and decide where to go in the next 24 hours. Now, after this meeting, which is 15 minutes, what often happens that, and this is the JChem Base team and the Cartridge team, what often happens that they get together in a focused discussion, dig down into something, understand the details somewhere, okay? And after some discussion, and everyone feels happy, that they discussed it, they understand it, they go back to work. Now, they often work in pairs. They develop the code in pairs. That's called pair working. The reason why they do that is to really make sure that they do the right thing and they do the right way. And what they also do is code review, in which they look at each other's work, the source code, in order to maintain high quality of the code. They strongly criticize each other's works, but in a very constructive manner. So they do this repeatedly for 2 weeks. It's a very short time. And when time is over, the game is over. Okay? They get together with the product owner in a meeting called the Sprint Review Meeting. Now, in this meeting, stakeholders and also users are welcome. So I encourage you to participate in these meetings. That's a Sprint Review meeting with the JChem Base team. Users are welcome. That's a great opportunity for you to collaborate with us, to see where the development is going, to see if it's on the right track, to see if your acceptance criteria will be met. I encourage you to participate. You're really welcome. Just Skype us or have a GoToMeeting with us, not with just JChem Base team, with any teams at ChemAxon. In this meeting, the Sprint Review meeting, the team demonstrates the work that was done during the course of the sprint. And based on what was done, what's been achieved, they decide what to do next. What will be the next product increment that they will build in the next sprint? But before doing so, they hold a meeting called the Retrospective meeting. And some people might call this a postmortem, but I just call it a retrospective meeting. Why do we do that? That's a fridge magnet, and it may sound really silly or banal, but that's the main reason why we do the retrospective meeting. We would like to unearth and reveal the problems we had in the sprint, in these 2 weeks. We would like to see the mistakes we made, really face with them, understand them, understand why did we fail to do something. Why? In order to avoid them in the next sprint. We don't want to make the same mistake again. So this happens in the retrospective meeting. That's a very nice 2 hours discussion with the team. We really would like to deeply understand how to improve the process. Oops, what's that? That's also a retrospective meeting. Yes, it's fun again. We play games. These games focus on very specific aspects of software development. Because software is a very complex thing. To build software is a really complex activity. But in these models, we can focus on one single specific aspect of software. Like here in this choo-choo train thing, when we built wooden rail tracks, we compared various aspects of the waterfall software development against the agile software development. And it provided us great learning points. We didn't conclude that agile is better than waterfall. We don't want to do that, because we don't believe that's true. But we wanted to compare them from certain aspects. Better understand what's agile, and what does agile differ from waterfall. So after the retrospective, we start a new sprint. Again, for 2 weeks, we have the planning meeting, and go. We build the next product increment. With these sprints, one after the other, the team develops the new feature, the new functionality, bit by bit, in an incremental and iterative fashion. Now, if in a stage we realize that something that was done before is not feasible anymore, we are happy to change it. Welcome, no problem. We are ready to redo anything, even everything if needed. Remember the keynote today about change? We welcome change in Agile, even late in the development. So basically, that's the Scrum Framework in a nutshell. Okay, it's so simple, very lightweight. Now, go back to the image of this tautomer search speed-up story card. The team worked on this story for several sprints. And after that, the new feature was done. How? What did they achieve? Look at this chart. On the horizontal axis here, you see various JChem versions, like 5.11, 5.12, and V6. On the vertical axis, that's the duration of the search, the time. How long did it take to perform a search? As you can see, version 6, the V6 engine, is more than 30 times faster in tautomer full structure search than previous version. That's really V6 performance, 30 times speed up. But remember the acceptance criteria of the tautomer search story? It said that it should work in full fragment search. Now, if you're not a search expert, don't be bothered what's the difference between full fragment and full structure search. But for us, this second case is the most valuable one, because that's what the user really needed. So what did they achieve? What does this chart tell? It looks a bit more complex. Now we have 3 curves. Again, on the horizontal axis, you see various JChem versions, 5.11, 5.12, V6, and 6.1. The red curve shows the time of typical searches, and the orange one, the average searches. The typical searches didn't take that long, like 5, 7 seconds. I admit that not the speed of light, but it's not that bad. What worries me is the average. If the average is so high, it means that there are some outliers, some searches that take really long time to complete. And some of these actually kill JChem search because they gobbled up the memory. Okay. And what's really astonishing can be seen on this chart. It's a bit different because here on the horizontal axis, you see the number of tautomers the various query structures have. And again, the vertical axis is the running time. So what you can see here, that various JChem versions, up here, these colorful curves, really slow down when the query has many, many tautomers, many different tautomers form. Okay, the more tautomers the query has, the slower the search in tautomer search mode. But not in V6. V6, the purple line, nicely touches the x-axis. That means not only really fast search, remember that's a V6 engine, really fast, but the performance is stable, is constant. Regardless of how many tautomers the query structure has, you always get the consistent same search speed. Okay? And that's astonishing. But there's more. Look at this chart. This performance improvement by a minimum of 1 order of magnitude was achieved in a smaller memory. Okay? Again, the x-axis is the number of tautomers, and now the curves tell the memory consumption in megabytes. And as you can see, previous searches could really crunch an immense amount of memory, like gigabytes, really. The new one, the purple one, has a very constant and consistent memory consumption. And what really intrigues me is that typically performance can be improved by the expense of using more memory. Okay, you can't achieve higher speed using less memory. But here they managed. That's fantastic. That's a great achievement. So for the team, it's time to celebrate. And we celebrate. And we have great achievement. We are happy and we enjoy life. What we do? We bake pancakes here and of course had some drinks. Okay. After celebration, I would like to introduce you another story. This one was about speed, and I know speed is important and never enough. You always want more. But what's even more important is the chemical intelligence in chemical search. So let's take a quick look at this story. The team worked on this story in the past year, and by that, they further improved JChem's chemical search intelligence. As I said, I'm not a product owner, so don't expect a detailed explanation from me. I'm a Scrum Master, I can't really explain that. But look at some cases. What's interesting and important here, the third case. There's a query structure and a target structure here. Okay? Now, these two molecules are tautomers of the same structure. But that means that they should match each other. Okay? This query should hit that target. But it did not. You lost one hit. I'm sure you lost more. But in V6, you get this hit. V6 not just improved performance, but also greatly improved chemical intelligence by enhancing the accuracy of tautomer search. Fantastic. More celebration, yeah. So that's JChem development from the inside. I believe it's not as messy as making sausages. So instead of this, it's more like this. We enjoy making JChem Base, developing JChem Base. Well, yes and no. Because beside of developing it, these teams should maintain and support it. What does that mean? Maintenance means fixing bugs here and there. And we do that. In the last year, the JChem Base team fixed about 120 bugs in JChem Base. What does support mean? Support means responding to your emails, your requests, your inquiries, also in the public user support forum. And ChemAxon support is known to meet very high standards, and that's one feedback that we consistently receive from you. Thanks for that. Just to illustrate the amount of work what this support gives us, let me just share a few raw data with you. Between January the 2nd and May the 22nd this year, one user of one key customer, just one single person, sent ChemAxon support total, okay, so not just JChem Base, sent ChemAxon support 706 support emails. I'm not kidding. I'm serious. Just one person. Only JChem Base received 187 requests from him in emails, and we sent 140 responses. I have to admit we are a bit lazy. If you look at the public support forum, and I don't know these figures by heart, but every year 140 new topics are opened in the public support forum. Altogether, on average, 800 posts. And what's important and interesting, and here I'm talking about the JChem Base forum only, that the average response time is 15 hours. Okay, so to do that is hard. It's very challenging. So what other challenges do we face with? Well, performance is never enough. You always want more. Okay? You want to process even larger sets of data and even faster than before. To meet this requirement, we have to improve the scalability of JChem search, both in the cartridge and both in JChem Base. Now this work, the so-called distributed search, has already been started. And Markush evaluators will be lucky, probably, to be able to evaluate this enhanced, faster search in the Markush evaluation this summer. The other challenge is the JChem Base API. Now you surely know that JChem provides lots of functionality, but it has a huge bloat API. It's overly complex. We have to get rid of that. But the challenge is that we can't just simply throw it away because it's been used by tens of thousands of users. Look at this chart. It shows how in the past decade the number of JChem Base and JChem cartridge users grew from 147 to almost 10,000. Mind that values in this chart are lower estimates. Actual figures are probably higher than that. So we have to design a much simpler, more elegant, concise, and ergonomical API while maintaining the existing one. Mind that while the number of users grew from 140 to 10,000, the size of the dev team, the guys who make this, JChem Base and JChem cartridge, grew from 3 to 9. And man, these are very dedicated, very knowledgeable, great developers. Okay. They are masters in chemical information, so the application domain, and also in software. Beside their mastery, they enjoy autonomy, just like all other teams in ChemAxon. And the third ingredient of high motivation and thus great success is knowing the purpose. Okay, knowing the purpose. And this can be best attained in close customer collaboration. And this is why UGM is a great opportunity for us. Okay, because we understand the purpose. We can speak to you and understand what you use our software for. So, Mads is saying that time is over. Let me briefly introduce what I talked about. JChem 6 greatly improved the correctness and consistency of tautomer search and thus provides high level of chemical intelligence. Okay? But just as human intelligence, chemical intelligence is very, very hard to measure. What's easy to measure is performance, the speed. And V6 gives you 30 times faster search on average in tautomer full structure and full fragment search. Remember this chart. And we enjoy high speed, just like you do. And we love tuning our V6 engine and boost even higher performance from it. Okay, we love that. It feels fantastic. And we are committed to make you the fastest chemistry search engine. But we also believe that what really matters is the chemistry intelligence. So we want to provide you the highest valued chemistry search intelligence on the market. And what we also believe is collaboration. We believe collaboration inside, within the dev teams, and in between the teams in ChemAxon and across the whole organization. And most importantly, we believe in collaboration outside. That means collaboration with you, with our users. So I would like to encourage you to strengthen your collaboration with us. Thank you all very much.